When we look at this, we realize that the only way you can factor this is by finding the greatest common factor. Do we see that? So this is a GCF situation. And just to keep it simple, we're just factoring out the X. So factoring out a negative X from each one of these leaves us with negative X times 29 thousandths X minus 5900 equals 0. After you've factored, whether it's GCF, simple, or complex, you then are going to take each factor and set it equal to 0. So we have negative X equals 0, and we have 0.029X minus 0.59 equal to 0. Well, this was pretty easy to solve, right? This is just what? X equals 0. And we know that because this is our start. We start on the ground. The frog started on the ground. Or started at distance 0. Yes. Okay. Now we're trying to figure out where did it land. So in order to solve this, what are we doing? What are the two steps that it's going to take to get X by itself? We're going to add 59 hundredths, and then we're going to divide 29 thousandths. Does that sound about right? So going to my handy dandy calculator, I'm going to hit Doc B and clear it out. I have, just so I'm going to go through the whole motion, 0 plus 59 hundredths gives me 59 hundredths. Then I divide by 29 thousandths, and it gives me 20, and we'll say 20.3, 20 and 3/10 approximately. So now we know X is approximately 20 and 3/10 meters. Okay, so that's my distance. That's the answer to part A. Okay, questions about the answer to part A?
No. Is there a situation where we verify to get the answer, or
You're always using your inverse operations, so it depends on what the problem is saying. Okay, then the next part, it says, what is the vertex? And that's because it's asking, what is the highest that the frog leaps? I'm looking for the vertex. Numerically, we can solve this. So just showing you numerically, and I'm going to show you graphically how you could solve for the vertex. So numerically, you know that the vertex is going to be halfway, right? That's the halfway point. And so if I know that I've gone 20 feet, 20 and 34 hundredths of feet, then my halfway point is when X equals 10 and 17 hundredths. So if I want to know how high I jumped, that means I'm plugging in 10 and 17 hundredths for X. So I would plug in Y equals negative 0.029 10 17 squared plus 0.59 times 10.17. And when I plug that into the calculator, it would tell me, oh, didn't mean to do that one. So plugging that in, I have negative 0.029 times 10.17 squared plus 0.59 times, and I get 3. So the height of the frog is approximately 3 meters. That's the highest he jumps. Okay, now graphically, what you're doing is you're putting in the equation and you're looking for the vertex. So we have negative 0.029 x squared plus 0.59 x. I'm going to graph it. I'm going to pull it into quadrant 1 because this is a positive problem. And I want to analyze where is the vertex. So menu, analyze, and we already established it is a max vertex. If you remember, just like you read a book, we read graphs from left to right. So we go to the left, click, go to the right, click, and it says, here is your vertex. Did we still get y equals 3? Yes. Yes. So it's totally doable by hand. But I wanted to also model it by calculator. Because our distance is, our highest point is our halfway point. And so if I know that the distance is 20 point, the total here is 20.3, what is halfway between 20.3? Okay. All right, and then the last thing is make sure you understand domain and range for this problem. So the domain, our domain represents our distance. What is the shortest distance the frog can jump? 0. And what is the furthest distance? That's your domain. The range is the height of its leap. What is the shortest height? 0. And what was his tallest height? 3. And that's establishing your domain and range for this frog. Okay, with the same logic, I would like for you at your tables to attempt example number 2, except instead of a frog, we're talking about a soccer ball. And so looking at example number 2, draw your graph, identify, and work through the steps that we did for example 1. I'm going to only give you a couple of minutes to see how far you can get, but it's the same thing that we just did, but instead of a frog, it's a soccer ball. Okay. So we have negative 300 x squared plus 1 and 6x. 1 and 60 x models the path the soccer ball was kicked. So hopefully you saw what I said about this being similar to the other problem. We're only in quadrant 1. And you have a soccer ball, it's being kicked, it goes up, and what goes up must come down. So it's going to come down. And the height is your y. The distance is your x. And it tells you there's a function that models it. And our function is y equals negative and 300 x squared plus 1 and 6/10 x. And it wants to know how far did the ball go. So first you're finding the distance from here to here. And if I'm finding the distance, that means I'm looking for x. So what is the x where it stops here at 0? And then if I'm looking for the height of the ball, that means I'm looking for the vertex. And we have a max vertex. Okay. All of this can be solved without graphic because it's math. You calculate it. So the first thing we have here is to set this equal to 0. So you have 0 equals negative 3x squared plus 1 and 6x. You factor out your 0. So we had factor out negative x, and we were left with 300x plus minus 1 and 6/10. We set each factor equal to 0. Negative x equals 0 is going to become positive. And then we have equal to 0. And to solve, all you're doing is adding and dividing. It's a 2-step algebra 1 problem. So then you divide. And so here, opening my calculator, I have 1 and 6/10 divided by. So now I know the distance. How far did the ball travel? 53 1/3 meters. That's the distance the ball traveled. If it's a common decimal, then yeah. Just so that it's not repeating and it's more exact. So 53 1/3 meter is how far the ball traveled. And then the second part wants to know how high. And we talked about that means you're finding the vertex. You can find the vertex by calculating or graphically. If you choose to calculate, what you're doing is you're finding the halfway point and plugging that value in. So the halfway point would be the distance divided by 2. And then I would plug that into the equation, the function. So we have negative 0.03 times the distance. Notice how you can arrow up and grab squared plus 1.6 times also the halfway point distance, and hit enter, and you get the value of 21 1/3 is how high the ball went. Okay, if that doesn't work for you, then you also can graph it. I'm going to hit tab, arrow up, and I'm going to put in the graph. Negative 3/100 x squared plus 1 and 6x. I hit graph. I can't see it in quadrant 1, so that means I need to zoom out. And now I can easily find my vertex. So menu, analyze, maximum, just like a book, we read from left to right. Did we still get 21 1/3? So then now we know that the maximum height of the ball, so the max height is 21 1/3 meter. Once you've established your maximums, you then can clearly state the domain and range. So the domain of this function, you should have gotten from 0 to 53 1/3. And the range of the function, you should have gotten from 0 to 21 1/3. Okay, I know a lot of y'all are probably looking for shortcuts mathematically, but this section is specifically about building your algebra skills, your arithmetic skills, your calculation skills, because there's going to get to a point, especially if you're taking pre-cal or calculus, where you do not have access to the calculator, and those skills will need to be utilized. Okay. All right. So those would be the two most difficult types of problems that you would work right now as far as solving using quadratics. We're going to talk about some simple problems that you may come across. This is an interest problem. So it's an interest formula. If you plan on doing accounting, economics, business, you will see a lot of basic formulas that are polynomial based when you are there, or statistics formulas. So here's an example of one. We have the simple area formula. Area equals P times 1 plus R to the T. Okay. And we're going to define what each variable means. A is what has occurred, like how much you've made, the amount you've made. Your new amount. Your P is your principal amount, your principal balance. What did you start with? Your R is your rate, and it's usually a percentage. And T is your time in years. So I'm going to take those values and substitute them in and solve for the unknown, which in this case is the rate. So how much have we earned? We earned 739. Our principal amount that we had was 600. Our rate is what we're finding. And this grew in over 2 years. Any questions about substitute the variables into the formula? Yes. Is that a stretch or a question mark?
Oh,
okay. All right. And now the purpose of this is, one, you check to see if there's any factoring that can take place. There isn't. So then you're going to then say, okay, all there is left for me to do is inverse operations. What inverse operation takes place first? When you're doing inverse operations, you want to do PEMDAS backwards. So you're starting. Is there anything I can add or subtract away right now? There's something I can multiply or divide away, which is the 600. This is 600 times. So the opposite would be to divide it. So I'm dividing this. And that's going to leave me with 739 over 600. We're going to practice leaving this as it is until the very end, okay? So we're left with 739 divided by 600 equals 1 plus r squared. Now I can deal with the exponent, right? And how do I take the square root. And what I do to one side, I do to the other. Again, we're saving it to the end. So we're left with the square root of 739 divided by 600 equals 1 plus r. And now I start back over. Is there anything I can add or subtract away? 1. So that becomes a -1. Adding -1 is the same thing as subtracting +1. Do we agree? Okay. This is what you're putting in the calculator. So now I'm going to go to the calculator and put that in. So in my calculator, oh, I don't want it that big. I'm putting in -1 plus the square root of 739 divided by 600. Hit enter. Is it okay that that 9 rounds to 0 to a 1? So I'm going to say approximately R equals approximately 1100, which means R is approximately 11%. How do we feel about using the interest formula? Okay, looking at this problem, where is a possible hiccup that you see? Yes, you're undoing things. So when you're solving, you're undoing PEMDAS. When you're evaluating, that means there's no equal sign, or you're just working one side, that's when you use PEMDAS. But when you're solving, you're going backwards. Inverse operations, okay? All right, example 4 is another simple formula. This is about the whole idea, what must go up must come down, right? So there's this object that's free falling, and the function to model that free fall is 16t squared. So basically it's on the top of something, and the object is doing this. Okay, that's what the object is doing. And the equation that represents it, S of t equals 16t squared. Okay, it tells us the height of the cliff. So we know that y equals 1600. And we want to know how long is it going to take for it to hit the ground. So how long is the object going to take till it hits the ground? That means that if we know our S of t equals 1600, then we set this equal and we solve. This is a 2-step solving. What do I need to do to get t by itself? I can't get. This is 16 times t squared. There's no plus or minus, so that means that I have to do division, because the opposite of multiplying 16 is to divide 16. So I'm left with 100 equals t squared. And now I can undo the square by taking the square root. And the square root of 100 is 10. So how long does it take for it to hit the ground? 10 seconds. Questions about free falling? Okay, 2 steps. Remember, inverse operations. If something's being multiplied, in order to move it, it has to be divided. All right, area. So taking it back to geometry. The area of a square porch is 64 feet. Find the dimensions of the porch. So you have your area of a square porch is 64 feet. And because it's a square, you know that the sides have to be the same, agree? And area equals length times width, which equals in this case, x times x, which is x squared, right? Agree? And this has to equal 64. What is x? 8. And that's because the square root of 64 is 8. Pretty straightforward. You just have to be willing to think about it. Maybe draw a picture if it helps you. Think about previous learned formulas. But it's not meant to stump you. It's meant to make you think. All right, the last one. You're again given a formula. This is about calculator demand, and it tells you that P is the price per calculator and X is the quantity. And it wants to know if the calculator costs $8, what would be the quantity needed? So it's telling you your P equals 8, which equals negative X squared plus 108. What do you need to do to find P? To find X? First thing, remember PEMDAS backwards. Is there anything I can add or subtract away to get to my X? I'm going to subtract the 108. That leaves me with negative 100 equals negative X squared. A negative on each side turns them both into a positive. And then I just have to do what? So then X equals how many calculators they would need to sell? 10,000. And that is the last and final type of problem. Yes. You can work on your exit ticket over the weekend. I will give you time at the start of class on Monday to do it. But if you want